The Arctic, a vast area and a top priority for the Norwegian government, unconnected until now.
We are situated far north. We've got very challenging topography in the country. We've got large ocean areas, and we have the Arctic island of Svalbard with human activity on it.
Well, it's always been clear that there's never been actually a good broadband data coverage to the areas around the North Pole. And that is because of the geostationary satellites. They are standing straight over the equator and they never reach up there. So there's always been a high need for getting this communication. And because Norway do have a responsibility in particular for search and rescue and also for national reasons, the need for communications in the Arctic, it has been a vital element for Norway to actually get this communication established.
Both for maritime activities, it would be important to have coverage. Search and rescue, it's very important for safe operations for people doing research in the polar region, certainly, and also for aircraft crossing through the Arctic.
Yeah, the problem with communications in the Arctic is not for Norway alone. It's actually for all nations which is surrounding the Arctic area.
Oppdraget vårt var å skaffe bredbånd til kommersielle brukere i norske interesseområder. Det viser seg veldig raskt at hvis du bare konsentrerer deg om norske interesseområder, så det området alt for lite, så vi måtte utvide til å se på hele Arktis. Denne nyttelasten som vi har laget sammen med Inmarsat, den skal sørge for å levere bredbånd til skip og fly, og den vil ha dekning i hele Arktis nord for 75 grader.
All options were investigated. The conclusion: build 2 satellites for a highly elliptical orbit.
Dette må jo sies å være drømmeoppgaven for enhver ingeniør, fordi noen har et behov, og så vet man enda ikke hvordan man skal løse dette teknisk. Og så får man frie tøyler egentlig til å prøve alle mulige varianter, og det var akkurat det vi gjorde. Vi fikk oppgaven med å skaffe kommunikasjon i nordområdene som ikke har kommunikasjon i dag. Og siden min bakgrunn fra satellitt, så satellitt det opplagte valget, men vi ble tvunget til å gjøre vurderinger på alle andre mulige tekniske løsninger også, men vi kom tilbake til satellitt med en gang. Et kommunikasjonssystem krever at du til enhver tid kan se en satellitt 24 timer i døgnet. Så det satellittsystemet som vi falt ned på, det var egentlig en modifisert geostasjonær type satellitt. Men vi måtte gjøre banen mer, vi klemte banen sammen for å gjøre den litt mer elliptisk, og så vippet vi den opp på siden, og på den måten så vil satellitten ha en litt forskjellig hastighet rundt i selve banen, og vi kan da gjøre det sånn at satellitten hviler lenger over nordområdene, og bruker veldig lang tid over den nordlige halvkule, og veldig kort tid på den sørlige halvkule. Og på den måten så skaffer vi et system hvor brukeren alltid ser en satellitt, og hvor du i opp til 2 til 3 timer hver eneste omløp ser begge satellittene samtidig. Og på den måten så sørger vi for at brukerne kan bytte fra satellitt til satellitt i et sånt tempo at de aldri mister koblingen.
Ja, bakkestasjonene har jo en veldig viktig funksjon i det her systemet her, fordi oppe i verdensrommet så svever jo de satellittene, men de må ha et plass å kommunisere ned på bakken, og det skjer via de her bakkestasjonene. Så bakkestasjonene har en veldig, veldig viktig funksjon. Vi har bygd opp en ganske formidabel infrastruktur i Nord-Norge for det her programmet her.
We have some very, very clever guys in the company which have done a fantastic job. We have a field office with very experienced people. Oddveig Tretterud as head of the field office. We have some Canadian engineers which are very experienced. Which is vital in order to ensure that the satellites are developed, designed and built with very high quality. But you need also to find out what are sort of the cyber cyber environment that you're going to enter into, so you need cyber specialists. We're going to have some classified stuff on board. That means that you need security people. You need to negotiate contracts. You need legal people on board. You need financial personnel. The satellites are very expensive. It is high risk to get out in space, so you need to have insurance.
Before embarking on this long journey, a team of top scientists had to be assembled.
First of all, it's important to have a very experienced team because when you build a spacecraft, there are so many engineering disciplines. So we need to have someone who has expertise in the different subsystems, and we need some overlap, but also, have a complete team so that we cover all the different areas.
ASBM is a large program with a high investment frame, and it became apparent that no single government or commercial company would be able to lift an investment like this on their own. Eventually, the U.S. Space Force, the Norwegian Ministry of Defense, and VSAT came on board.
So we understood very, very soon that we had to get more parties on board. We had to establish a cooperation with other satellite operators and with the government in order to make this actually a viable program. Also, a very nice process in the military, Ministry of Defense, where the satellite division or space division, which was headed by Stig Nilsson, was instrumental in getting the Norwegian Ministry of Defense to sign up actually to have then a X-band payload, a military payload on board. They needed that for the Coast Guard, they needed it for forces operating in the north, in northern Norway, in particular in Troms. It is a lot of satellite shadows because of all the mountains and valleys. So they also needed a different system than geostationary satellites to get satellite coverage actually on the Norwegian mainland. And then we were in the US together with the armed forces on a space meeting, and we got the opportunity to talk about the Norwegian plans. And in the break afterwards, and this is a very interesting story, Rachel Morford, a US Air Force employee, came up to me in the break and asked, "Do you have space for another payload on board?" Well, I'm sure we can do that. And then the ball started rolling with the US Space Force.
Our key suppliers, Northrop Grumman and SpaceX, were chosen early on.
It's a matter of fact that SpaceX, since 2016, and that was 3 years before we negotiated the contract with SpaceX, has not had any accidents. So when you are selecting a launch provider for a complicated program like the Arctic Satellite Broadband Mission program, you want to make sure that you are actually getting your satellites up in space.
The satellites are designed to last at least 15 years in space and have undergone rigorous testing.
Building a satellite of this size is a manual process. The satellite is big. It's 3 by 3 by 4 meters. It has hundreds of thousands of components. All this is put together by hand. So this is a complicated process.
Yeah, like a 15 years lifetime is a very long time, especially when you take into account that you can't do any repair on any of the hardware. That means we have very tough requirements for all the hardware that goes into the satellite. So we start with a unit level testing. Every unit is a exposed to very tough test environments. We test even, first of all, the functionality and performance, but then we also test for the space environment, vacuum, and the launch environment. Then we do basically the same when we have installed each of the subsystems. So again, a repeat of basically similar tests to we did on the unit level. And then again, we repeat that when we get to the system level. So overall, there is a very tough regime that we have to expose all the hardware to.
Satellitten må demonstrere at den kan takle sterk varme og sterk kulde, og vi må sørge for at alle systemer som skal hjelpe til å holde satellitten i riktig temperatur, at de virker som de skal.
We signed all the contracts in 2019, started building the 3 July in 2019, and now we're building satellites for almost 5 years. So this is a long march towards something which is strategically very important. And one of our focuses here has been we need to collaborate, we need to have a good dialogue, we have the common objective. So in order to make this fly, you need to do it on a footing of collaboration and good dialogue.
SpaceX will launch our 2 satellites on a Falcon 9 rocket from Vandenberg Space Force Base, California.
I vårt system så setter vi da satellittene oppå hverandre og skyter begge satellittene opp på samme rakett. Når satellittene slippes fra raketten, en etter en, så vil vi bruke rakettmotorene på satellitten sånn at de skiller lag, sånn at den ene satellitten vil være over nordlige halvkulen og den andre over den sørlige halvkulen.
So that takes, several days. So we have almost 2 weeks with orbit racing before we get into our final orbit. And during that time, we also start testing the bus or the platform, so to speak. So we do all that while we kind of get slowly up into the correct orbit. And when we arrive on station, which this is actually an elliptical orbit, so, we rotate on a 16 hours period. But then we start testing each of the payloads. And that takes, several weeks as well. So from the launch until we actually do the handover and accept the spacecraft in orbit, it takes about 2 months.
Så funksjonen til bakkestasjonen er jo å sørge for sikker og stabil kommunikasjon fra bakken opp til satellittene. Og vi har jo 2 satellitter i drift, så du kan si når den ene er aktiv eller synlig, så er den andre på andre siden av jorda. Og så roterer de rundt, og så kommer jo da den neste opp og blir synlig, og alt det her krever jo en slags kunst i koordinering, og nesten en slags koordinert dans da, mellom bakkestasjonen og satellittene for å få det her til å fungere sømløst. Og sømløst er på en måte nøkkelen i det vi skal levere fremover.
So we have 4 payloads then on board, the satellites, actually 3 payloads on one and 4 on the other. And all of them will serve its strategic interest of nations and allies in 15 to 20 years to come.
After launch, our satellites will perform the orbit raise using their own engines. while waking up and deploying the sun arrays in antennas.
On behalf of the team and of Space Norway, I'm very proud that we've been able to bring this project now to up to a launch, and it's really been a fantastic journey, and it's been a fantastic team, and I think they'll be doing great things in the future as well.
We have all a reason to be proud of what we have done. First of all, we are providing communication capabilities to people in the Arctic that never have had that opportunity. The main reason. We have put together a program that has put Norway on the map as the prime Arctic space provider. And there's nobody else that are close to what we have been able to do here. From small resources with a handful of people. Everybody that we have worked with is very satisfied for the collaboration and the way we have managed this.
Jeg veldig, veldig stolt over det vi har fått til. Dette er noe som en kanskje får lov å oppleve en gang i livet. Så jeg ser veldig frem til den milepælen som launch er, for launch er en veldig, veldig viktig milepæl. Og så vet vi da at launch er på en måte avslutning av noe, og så er det begynnelsen på noe helt nytt.
Jeg tror nå så er man i en situasjon hvor man er så spent, og man har så mye å gjøre, og det er mye som skal falle på plass i siste liten. Så nå gleder vi oss veldig. Vi er veldig spent, men jeg tror nok kanskje at først etter en stund så forstår man hvor stort dette egentlig er. Og jeg er helt sikker på at jeg kommer til å være veldig stolt, og helt sikker på at dette er høydepunktet i karrieren. Det er helt bombesikkert.
But in a few minutes now, we're going to see the satellites take off from Vandenberg at the US Space Force base in California. And of course, we're pretty comfortable that the satellites now are tested many times, and that they will work when they get out in space. But that's not something you can't take for granted. There is risk linked to a space program, but let's hope that everything goes as it's planned to go.